My name is Elizabeth Komives, and I'm a professor of chemistry and biochemistry at UC San Diego. I've been there for 28 years, so I came and sat in on a few of the lectures that the participants were receiving that day, and I got to see the labs and understand what the project is that they're doing. And the first thing I would like to say is the students in SSP, this is the third week of their program, and they have already learned to speak the language of biochemistry, which I was very amazed about the level of the questions they were asking, and they learned all that in the lectures, the coursework that's part of this program. And I think that's one of the things that's really unique, is a lot of research experiences that high school students have, they just kind of get thrown into a lab and they're told to do things, but they don't really understand why they're doing it or what exactly are they doing. They're just doing stuff. And SSP has this amazing combination of giving them the college level course material, but explained in a way that the students understand it. And then when they go into the laboratory or onto the computers to do the project, they actually understand what they're doing and the background behind it and why they're doing what they're doing. And so that's, to me, really an impressive part of the SSP program. And then the other thing that I really think is great is, you know, before I came here, I was thinking, okay, so how did they devise a research project that has a high likelihood of working, but at the same time, they're doing something that's never been done before? And this fungal phosphatase project is just really perfect, because there's millions of species of fungus that infect different crops and even, you know, some of them that infect mammals or humans. And they all have this conserved pathway that they use to mess up the organism that they're infecting. And so, you know, there's a phosphatase in every one of these dangerous funguses that has not, fungi, that has not been characterized before. And these students are isolating the gene for that fungus. They're expressing the protein from that gene in E. coli. They're purifying the protein. They're studying its substrate specificity, and then they're using that information to design an inhibitor using computational approaches. And I mean, just the wealth of different cutting-edge scientific approaches that the students learn in this 6 weeks because of the way this project is designed is unbelievable and really exciting. And whoever designed this project really, I mean, they did an incredible job. In terms of who should come to SSP, the students that I've met here are from different countries, different backgrounds. Some of them, you know, have gone to schools where they've had every opportunity, and others have gone to schools where they haven't had as many opportunities. But they're clearly engaged and interested and wanting to go deeply into the experience of science. And I think, you know, SSP, one of the really important things that SSP does is it gives high school students the experience of what real science is, because real science is discovering something that we don't already know. And that's not the experience that high school students get of what science is. So if someone is interested in discovery, I think SSP is an amazing way to spend some time in your high school junior to senior year transition to really experience the excitement of science. In terms of who might want to teach in this program, I think anybody who's passionate about widening the pipeline of students from diverse backgrounds coming into STEM. And I would say that I think it's important that it has to be a research faculty member, someone who knows how to do research and is interested in transmitting the excitement of research to a group of extremely bright high school students.